For millennia, the moon has been our constant companion, lighting our nights and shaping our tides. Its familiar face, marked by craters and plains, is woven into our myths and science. But here's the secret. We only ever see one side of the moon. No matter where you are on Earth, the same features always face you. This led to a powerful question. What's on the other side? For centuries, the far side was a blank canvas for imagination and myth, dubbed the dark side, and a place of mystery and speculation. Before the space age, no human had ever seen it. The quest to unveil this hidden face became a story of exploration, requiring us to leave Earth and look back at our lunar neighbor from a new perspective. Seeing the far side wasn't just about curiosity, it was about completing our understanding of the moon. It meant turning myth into science and learning more about the history of our world and solar system. The moon's hidden face became a symbol of the unknown, waiting for us to explore. The journey to reveal it would change our view of the cosmos forever. And it all began with a simple, unanswered question. What lies beyond the familiar face we see each night? The phrase dark side of the moon is misleading. The far side isn't always dark. It gets just as much sunlight as the side we see. The reason we never see it is tidal locking. The moon rotates at the same rate it orbits Earth, always keeping one face toward us. Imagine circling a friend while always facing them. You'd have to spin as you walk. The moon does the same. So one hemisphere is always hidden. Both sides experience day and night, each lasting about 2 Earth weeks. The far side is only dark to us because it's out of sight, not out of sunlight. A better name is the far side of the moon. When the far side is sunlit, the near side is in darkness, and vice versa. The myth of perpetual darkness is just a trick of perspective. The moon is a rotating sphere, with every part illuminated over the course of a month. The real mystery isn't darkness, it's what's actually there. When we finally saw the far side, it was a shock. It looked nothing like the near side. The near side is covered in dark, smooth plains called maria, formed by ancient lava flows. The far side is rugged, mountainous, and densely cratered, almost devoid of maria. This stark difference is due to the moon's crust. The far side's crust is much thicker. Impacts on the near side broke through the thin crust, letting lava flood the basins. On the far side, the thick crust kept the surface rough and ancient. Why is the crust so uneven? The leading theory is that Earth's gravity influenced the cooling moon, making the near side thinner. The far side preserves a more ancient, untouched landscape, a relic from the solar system's earliest days. The moon's 2 faces tell a story of cosmic violence and planetary evolution. For millennia, the far side was unseen, until 1959, when the Soviet Luna 3 sent back the first images. Those blurry photos revealed a rugged, cratered world unlike anything we'd imagined. Later missions mapped it in detail, but no astronaut has ever set foot there. All landings have been on the near side, where communication with Earth is possible. In 2019, China's Chang'e 4 made history with the first soft landing on the far side in the South Pole Aitken Basin. This required a relay satellite to maintain contact with Earth. The U-22 rover explored the surface, using radar and spectrometers to study the geology and composition. It found layers of rock and soil shaped by ancient impacts and evidence of material from deep within the moon. These discoveries offer a direct look at the moon's interior and its violent history. The far side is no longer a blank map. It's a new frontier for science. The far side's value goes beyond lunar science. It's the quietest place in the inner solar system for radio astronomy. Earth is filled with radio noise, but the moon blocks it, making the far side perfect for listening to faint signals from the early universe. A radio telescope here could reveal secrets from the cosmic dark ages before the first stars formed. The far side's untouched surface is also a record of solar system history, preserving craters erased on Earth. By studying these craters, we can piece together the timeline of planetary bombardment. The South Pole Aitken Basin remains a key target for future missions. Returning samples could revolutionize our understanding of planetary formation. The far side is no longer a place of myth, but a frontier of discovery. It holds clues to the moon's origins, the history of our solar system, and the birth of the universe itself. The journey to explore its secrets is just beginning. The far side invites us to keep looking beyond the familiar into the unknown.